Given two rectangles on the 2D plane, please design an algorithm to find whether these two rectangles overlap each other. That's about today's video. Let's dive in. San Francisco Bay Area, or Silicon Valley. This is where my dream started. Hi everyone, this is Steve here. Today we are going through LeetCode problem 836, rectangle overlap. Now let's go through the problem description first. A rectangle is represented as a list of x1, y1, x2, x2, where x1, y1 are the coordinates of its first bottom left corner, and x2, y2 are the coordinates of its top right corner, bottom left and top right. So with these 2 points set on the 2D plane, we know exactly where the rectangle is lying on the 2D plane, right? So that's what we were given to know where this rectangle is on the 2D grid. So two rectangles overlap. It's giving us the definition of what is called an overlap of two rectangles. Two rectangles overlap if the area of their intersection is positive. To be clear, two rectangles that only touch at the corner or edges do not overlap. So if two rectangles, they have each one of them has an edge that overlap with each other, they are not called overlapping each other by this definition. Given two rectangles, return whether they overlap. So we're given two rectangles. We are asked to return to figure out whether these two rectangles overlap each other. First one is this. 0, 0, 2, 2, 1, 1, 3, 3. Let's just draw a 2D grid on x and y axis so we can figure out. Right, I've driven this 2D grid on the given an x and y axis, so we can see, suppose this is x axis by convention, and this is y axis. This is y axis. So we can see here. And the example we were given, the first example is this rectangle and this rectangle. So let's figure out this rectangle by its definition. The first two are its x and y, meaning the bottom left, 0, 0, right? 0, 0. This is 0. X coordinates 0, y coordinates 0, 0, 0 here. And its top right coordinates is 2, 2. Top right is 2, 2. x2, y2. So this is the first rectangle defined by the first coordinates given, right? Defined by the first coordinates given. How about the second one? The second one is 1, 1, 3, 3. So we see here, here is 1, 1. On x-axis is 1, y-axis is 1. So the top and bottom left corner of the second rectangle is 1, 1. 3, 3 is here, 3, 3. So 3 on x-axis, 3 on y-axis. So 3, 3 is here. This one is the second rectangle. Clearly, we can see these two rectangles overlap. This is the overlap area, right? This is the overlap area between these two rectangles. So the result is true. We're going to return true here. The second example, let me draw the second example. All right, here is the second example. The second example, we're given 0, 0. We're given 0, 0 as the bottom left corner. And then 1, 1. 1, 1 is here. So this is the first rectangle we're given. The second rectangle is 1, 0. 1, 0 here. This coordinate is bottom left. And then 2, 1 is here. 2, 1 is here. So with these two coordinates, we know where the second rectangle is. So this is the second rectangle. This is the first rectangle. Per definition of this problem, if the two rectangles only touch each other at the corner or edges, that means they don't overlap by this definition. Okay, so these two edges, they just touch each other. So they don't count as overlapping each other. Okay, that's why it's returning false. Okay, very clear after we draw the diagram. Then let's try to think about what's the formula or what's the pattern, or using what kind of math can we figure out, because we're only given two points identified by 4 coordinates. Then we know whether these two rectangles overlap each other. This is on the 2D plane, right? On the 2-dimensional plane. Let's think about that in the 1D scenario. So just think about, say this is just 1D, one segment. Let's see, one segment we can identify it by using x1, we'll just call it left 1. On the 1D plane, we can use left 1 and right 1 to indicate this is one segment. And we can have another one called the left, another segment indicated by left 2 and right 2, like this, to indicate this is another segment. How can we know that? So what are the possible? First, let's figure out what are the possible positions, the possible intersection relationship between these two segments. So remind me tomorrow. This is one. This is case one. Case one. This is one case. Apparently, we know these two segments overlap each other. Another case is, copy this. Case 2 will be looking like, move all of these towards the right. In this case, these two segments don't overlap each other, right? What about the other cases? The other case is just going to be the other way. So let me just copy this. It's basically identical. Case 3 is just going to be this. This one is on the right side. These are the three cases. How can we identify these two segments are overlapping each other on the 1D plane? This is 1D. This is just one segment, another segment. A few conditions, both necessary and sufficient. One is that we know there must exist one point on this 1D plane that's going to meet this condition. Left is smaller than, this point is smaller than left 1 and smaller than right 1. This is for sure. This is for sure. This is one condition, because this is very implicit, right? Left 1 on the 2D plane, left side must be smaller than right side. So there must be one point on this 1D plane. The same is also true for left 2 and right 2. Let me just copy this over to here so that we don't need to, we have more space to write. I'll just write everything down here. This is one. There must exist one point x, which is somewhere here. Every point on this in this space will meet this condition, and the same is also true for left 2 and right 2. For left 2 and right 2, this is very implicit, right? There must be such a case. Another one is that there must exist a point. If this, see, we're looking at case 1 here. So case 1, we know that these two segments do overlap. Then it means left 1, there must exist a point which makes this condition hold. Right 2. Left 1 is here, right 2 is here. There must exist a point somewhere here. From this graph, we can clearly see such a case. And another case, which is left 2 greater, there must exist another point x is greater than left 2 but smaller than right 1, between here and here, right? Which is also true as well. So from the second condition, what can we get from, what can we derive from the second condition, which is what we're going to get is left 1 must be smaller than right 2, right? Left 1 must be smaller than right 2. So we just remove, we take the x out of this picture. The same, we can take the x out of this picture as well. Left 2 must be smaller than right 1. Left 2 must be smaller than right 1. Otherwise, there is no chance that these two segments are going to overlap, right? If you see here, this condition doesn't hold for this case, right? Left 1 is smaller than right 2. Yeah, that's true. But left 2 is here. Left 2 is actually greater than right 1, right? So this condition doesn't hold. So this one, this entire and condition is going to fail. So case 2, it doesn't hold. These two segments don't overlap, right? With this graph and with and how we can derive these conditions from this graph, we can clearly understand this is the sufficient and necessary conditions to have the two segments overlap each other. All right, with this is on the 1D plane, and with this understood, we can extend this to a 2D plane. How can we identify a 2D, on the 2D plane, how can we identify a rectangle? We use, as this problem says, we use 2 points. One is the bottom left, the other is the top right. So as long as, so basically we can think about the rectangle on the 2D plane, just a shadow. There's a shadow on the x-axis, and there's another shadow on the y-axis. And everything, as long as these two rectangles, see this is the correct, this is the two rectangles that overlap each other. Then we can see if these two rectangles, they overlap each other on x-axis. So we put the 2D shape onto a 1D shape. If the two rectangles, they overlap each other on x-axis and on y-axis, then we can know that these two rectangles, they do overlap each other. I hope this is all clear. See, here on x-axis, for the first rectangle on x-axis, it's 0. And in another corner is, so we're putting this rectangle to 0, 0, and 2, 2 into x-axis, and then there's y-axis. So we compare, so basically that one becomes left and right. Left 1, right 1, left 2, right 2. So we compare both. This is left 1 and this is left 2. We can just put these two coordinates, these two and this two, take that into this condition. Then we can figure out, as long as these two rectangles, they overlap each other on x-axis and also on y-axis, we can be sure that these two rectangles overlap. Basically, as long as they meet these conditions, these two rectangles overlap. I hope that is all clear. Then let's start putting that into code. So here, left 1 is basically going to map to rec 1. So 1 is just standing for the first rectangle, and here left 2, right 2 is standing for rec 2. First rectangle and second rectangle. That's what 1 and 2 stands for. So then let's put this condition into, so remember, we'll just put the 2D into 1D, into one 1D and another 1D. Basically put that into x-axis and y-axis. So we're going to double this, right? This is just for 1D. We'll write this condition for x-axis and also write this condition again for y-axis, as long as the two segments overlap in both 1D dimensional, we can conclude that these two rectangles overlap. All right, with that said, let's see. Left 1, right 2. That's going to be, let's just put return rec 1. Rec 1 is left 1. Which one is left? Left is, let's consider x-axis. X-axis, x-axis, that's going to be at 0, at indexes, is going to be 0 and 2, right? So that is x-axis. Then for y-axis, it's going to be 1 and 3. So here, this is 1 and 3 for the first rectangle, and then this is 1 and 3 for the second rectangle, right? So now what we need to do is to put the rectangle, which is on the 2D plane, again on the x-axis, to compare whether all of the x-axis, they meet these two conditions, and again put the y-axis, shadow that onto the y-axis to see if those two coordinates of the two different rectangles meet these two conditions as well. Okay, so now let's do that. Let me just copy this one over here so we have a clue of what's going on. So for x, let's do x-axis first. So here again, this left 1 is just mapping to rec 1, 2 just mapping to rec 2. So it's going to be rec1 for x-axis is going to be 0 and 2. So we'll compare 0 needs to be smaller than rec2's 2. So left 1 is going to be smaller than right 2. And left 2 is rec2. Let's put rec2 here. Left 2 is going to be 2. Needs to be smaller than left 1. So it's just rec1. Right is going to be, actually this is 2. Right side is going to be the second one, and here left side is the point at 0 index. All right, that's just write it this way to make it more readable, to know what we're doing. This is the condition for x-axis. Then we need to do the same thing for y-axis. So instead of using 0 and 2, we use 1 and 3. That's going to map us to the y-axis. Then that's going to be, again, same thing. Left 1 maps to rec1. Left 1 and the right 1 maps to rec1. Right 2 and left 2 maps to rec2. The numbers do map. And then here, left 1, remember now we're doing on the y-axis. So it's going to be 1 and 3 needs to be smaller than rec2's 3. The same thing here, rec1's left is going to be left 2. We need rec2. And then here, left is the first one. So first point on the y-axis is going to be 1. And then right 1 is going to be rec1. And the right point, which is the second one, which is the second point on the y-axis. So it's rec3. That's it. As long as all of the 4 conditions hold, remember this line stands for the conditions we need to meet in order for the two rectangles, for these two rectangles to meet on x-axis. And this one stands for the two conditions, in order for the two rectangles to overlap each other on the y-axis. That's it, to put that on the 2D plane. So we simply extend the conditions for these two rectangles to meet from 1D plane to 2D plane. That's it. That's the solution. Let's hit submit and see. Accepted. 100%. This is a big shout out to, I think this problem, is contributed by Lee215. He's a super genius guy. And he also posted the solution. I'm totally inspired by him. He put, these are the sufficient and necessary condition. He explains it super well. I'm just putting that into a video. These are the conditions, C++ version and Python version. That's it. That's why it's so quick, 100%. This is just an O1 time and O1 space. There is no complex data structures involved. That's it. So that's why it's 100%. I believe everybody who submits solution using this way is going to be 100% because it's really fast. There's no extra space needed, no fancy complex data structures needed. As long as you can understand the logic, the reasoning behind it. That's it. A big shout out to Lee215, super user. That's it for this video. I hope this understanding, this explanation makes a lot of sense, makes this problem easier to understand for everybody. If you like this video, just tap the like button. I'm going to appreciate it a lot. And don't forget to subscribe to my channel. That's going to help a lot with the YouTube algorithm. Thank you very much. I'll see you guys in the next video.